Welcome to the educational research section of www.happynumbers.org. Today's video is going to deal with the different types of experimental research designs. We'll talk about pre-experimental research designs, quasi-experimental, and true experimental research designs. But first, we need to get some vocabulary under our belt if we don't have it already. There are some really important concepts, and this vocabulary you will need to know. In a research study, an independent variable. The independent variable is the treatment or the intervention that is being introduced to bring about change. The independent variable is the treatment or the intervention that is being used to bring about change. In essence, it's the cause in a cause and effect relationship. So it's the treatment or the intervention. A way maybe to remember that is independent begins with I and intervention begins with I. So independent variable is the intervention or the treatment that is going to bring about the change in the dependent variable. And the dependent variable, the change or difference in behavior that occurs as a result of the independent variable, the effect in a cause and effect relationship. Now, one easy way to know exactly what a dependent variable is, if you're looking at a piece of research, is you ask yourself the question, what data is the researcher collecting? So if the researcher is collecting data on reading scores, well then the reading scores is the dependent variable. If the researcher is collecting data on mathematics performance, then the mathematics performance is the dependent variable. And then you just ask yourself, well, what is the treatment? What is the intervention that's being used? And that would be your independent variable. Let's take a look at a couple of examples here. Suppose we had, just from the title of this research, the effects of positive reinforcement on successful homework completion in a 5th grade math class. Well, okay. So I'm going to ask myself the question, well, what is the researcher collecting data on? What are they going to collect data on? Well, they're going to collect data on homework completion. So homework completion is the dependent variable. By the way, the word data begins with D and dependent begins with D. So if we ask ourselves, what's the researcher collecting data on? Well, homework completion, so that's the dependent variable. Now we ask ourselves, what is the intervention here? What is the treatment? Well, it says the effects of positive reinforcement. So positive reinforcement is the intervention, and therefore positive reinforcement is the independent variable. Let's take a look at this. Teaching single-digit multiplication facts using the constant time delay strategy. Well, what is the researcher collecting data on? What's going to be collecting the data on? Well, teaching single-digit multiplication facts. So they'll be collecting data on how well students are doing with their learning their multiplication facts. That would be data, dependent variable. What is the intervention that's being used, or the treatment? Well, a constant time delay strategy. So the independent variable, or the treatment, would be the constant time delay. Let's take a look at this one. Using word processing to improve writing quality in a freshman English high school program. I'll give you a few seconds to figure that one out. Okay. Well, what are they going to be collecting data on? Well, they're interested in writing quality. So that is the dependent variable. They're collecting data on that. And what is the intervention that they're using? Well, using word processing. So word processing would be the independent variable. Okay, so those are two very important terms that we need to know. Another term we need to know are extraneous or confounding variables. And extraneous or confounding variables are any variables that offer alternative explanations other than the independent variable or the treatment for the results. So if there are other variables lurking around that offer alternative explanations, then we cannot say with a high degree of probability that it was the independent variable or the treatment. Another term that's important, internal validity. And that is the degree to which experimental research results are attributable to the independent variable or the treatment and not to some other rival explanation or some other extraneous or confounding variables. So if we can say with a high degree of probability that it was the independent variable that caused the change in the dependent variable, then that research has good internal validity. Another term, external validity. The extent to which the study results can be generalized to groups and settings beyond those of the experiment. In other words, if we can apply the settings of a piece of research to different populations, different settings, different situations, then that research has strong external validity. Some research, especially true experimental research, uses hypotheses, which are a specific statement of prediction. And we'll talk about the null hypothesis and alternative hypothesis. We don't have to, directional and non-directional. You'll actually read about that. So we don't have to go into that now. But just be aware that experimental research, especially true experimental research, is usually hypothesis-driven. All right, so let's take a look at some pre-experimental designs. Now, the way this is, I'll explain this to you. This is a one-group pre-test, post-test design. So we have a group, we pre-test them, we give them a treatment, and then we post-test them. Now, this will have very, very weak internal validity because there could be many confounding variables as to if we have significant differences between pre and post-test scores, there may be many extraneous or confounding variables that cause that difference. So we need to be very careful. That's why this is a pre-experimental design. This is a good design to use if you're curious about something in your classroom or something like that. But other than that, it has very weak internal validity. And here are the threats to internal validity that are not controlled for by this design. There is a video on internal validity. If you have not read that, then these may not make any sense to you, and you may want to come back and visit this after you've gone over that video. But this is a very simple pre-experimental design. Pre-test, treatment, post-test. Very weak internal validity, but good for sort of trying to identify the possible good intervention or treatment. This is another pre-experimental design called a static group comparison. So we have a treatment, we have one group and we have a treatment and a post-test, and we have another group and we have a treatment and a post-test. Now this has very weak experimental control or internal validity also. One of the major problems is there may be differences in the two groups. Maybe we're using, let's say, the two classrooms, so they come with built-in differences already that may explain the differences if there were differences in the post score. So, two or more comparison groups, group 1 experimental, group 2 control, but they were not randomly assigned, they were existing class. So this makes this a very weak design. Again, that's why it's a pre-experimental design. However, that although it's weak in terms of internal validity, it doesn't mean that it may not be valuable, because it may be a good preliminary design to use if we're trying to compare two different treatments. Now, quasi-experimental research, it may not always be feasible to randomize. We may not, especially if we're working in schools, we're not going to be able to break up classes and randomize students to one group and another group. And control or comparison groups are unavailable. Usually stronger, the quasi-experimental, usually stronger than the pre-experimental designs, but not as strong as true experimental designs, and we'll take a look at one. Here's a non-equivalent control group. We have a pre-test, and then a post-test. We have pre-test, we have a treatment, post-test, pre-test, treatment, different treatment, post-test. There's no random assignment of subjects, uses existing groups, usually classes, makes groups as equivalent as possible. Treatment should be randomly assigned. And here are some of the possible effects. Oh, sorry. Now, here is true experimental research. True experimental research. True experimental research is the only research methodology that can examine cause and effect relationships. No other research methodology can talk about cause and effect. The two distinguishing characteristics of true experimental research are random assignment to groups, experimental group and control group, random assignment, and manipulation of the independent variable or the treatment. The researcher manipulates which group gets the treatment and which group does not. It deals with independent and dependent variables, which we've talked about, and it's characterized by a theory-driven research hypothesis and a statistical equivalence between randomly assigned control and experimental groups. So random assignment to groups and manipulation of the treatment. Here's what one of the designs what this might look like. By the way, the R means that Group A was these participants were randomly assigned to Group A, and participants were randomly assigned to Group B. This is a very standard way of looking at research methodology. It's a very standard notation. That's why I've put it here. So, random assignment to Group A, random assignment to Group B. Pre-test for both groups. One group gets treatment, one group doesn't, and the researcher controls that, so that's the manipulation of the independent variable, because that's the treatment, and then post-test in both groups. This is true experimental research. This can lead to making statements about cause and effect relationships. Well, that is it for true experimental research. Thank you very much, and we will see you next time.